Imagine a ship so massive it could carry an entire city, or so heavy it would sink the moment it touches the water. Today we're diving deep into the fascinating world of sea giants and uncovering the secrets behind the maximum size and weight of ships. Get ready for an epic journey through naval engineering, physics, and maritime history. You'll never look at a ship the same way again. Welcome. You are watching Quirk Orbit. Before we set sail on this adventure, don't forget to like, subscribe to the channel, and share with your friends. The titans of modern seas. Right now, as you watch this video, real giants are sailing across the world's oceans. The largest cruise ship currently is the Icon of the Seas by Royal Caribbean International, with an impressive 250,800 gross tons. Imagine this. This giant can transport up to 7,600 passengers, plus a crew of 2,350 people. It's like a small city floating at sea. But cruise ships aren't the only giants. In the world of cargo transport, we have the MSC Irina, a container ship capable of carrying 24,346 TEUs, or 20-foot equivalent units. To give you an idea, if we lined up all these containers, we'd have a line almost 150 kilometers long. These ships are true marvels of modern engineering, designed to push the limits of what we thought was possible. But have you ever wondered how something so large and heavy can float? Well, the answer to that question takes us to the next topic, where we'll dive into the fascinating physics behind buoyancy. Get ready for some surprising revelations. The physics of buoyancy, the secret of Archimedes. You might have heard of Archimedes, the Greek scientist who ran naked through the streets shouting, "Eureka!" Well, it was he who uncovered the mystery of buoyancy over 2,000 years ago, and his principle still forms the basis of modern naval engineering. Archimedes' principle states that a body immersed in a fluid experiences an upward buoyant force equal to the weight of the fluid displaced. In other words, for a ship to float, it must displace a volume of water whose weight is equal to or greater than its own weight. This explains why a steel ship, which is much denser than water, can float. The secret lies in the design of the hull, which is engineered to displace a large volume of water. The submerged part of the ship creates a hole in the water, and the weight of the water needed to fill that hole is greater than the weight of the ship itself. But buoyancy is just the beginning. Naval engineers must consider many other factors when designing these sea giants. Weight distribution, stability, and structural strength are just a few of the challenges they face. And speaking of challenges, have you ever wondered what the real limits are for the size and weight of a ship? Next, we'll explore the frontiers of naval engineering and discover what really determines the maximum size of a ship. Get ready for some surprises. The limits of naval gigantism. You might be thinking, if we already have such large ships, why don't we build even bigger ones? Well, the answer isn't that simple. In reality, there is no absolute maximum limit for the size or weight of a ship, but several factors impose practical restrictions. First, there's the issue of buoyancy, which we've already discussed. A ship must displace a volume of water equal to its weight to float. But as size increases, the relationship between volume and hull surface changes, which can affect stability. Another crucial factor is port infrastructure. Ports have limitations in terms of depth and berth size. A ship that can't dock at any port isn't very useful, is it? Additionally, there are restrictions imposed by canals and locks. The Panama Canal, for example, limits the size of ships that can pass through it. This led to the creation of the Panamax class, which defines the maximum dimensions for ships wanting to cross the canal. Naval engineering also faces technical challenges in building very large ships. Structural strength, weight distribution, and propulsion become increasingly complex as size increases. Finally, we can't forget international safety and pollution prevention regulations, which also impose limits on ship size. But if these are the current limits, have you ever wondered how ships will be in the future? In the next topic, we'll take a peek at what technology has in store for the future of navigation. Get ready for some ideas that seem straight out of a science fiction movie. The future of navigation, innovation at sea. The future of navigation promises to be as exciting as an adventure movie on the high seas. The maritime industry is undergoing a true technological revolution, with innovations that promise to completely transform how ships are designed and operated. One of the most promising trends is the development of autonomous ships. Imagine vessels capable of navigating, monitoring, and even making decisions in real time without human intervention. These ships use artificial intelligence and advanced sensors to minimize human error, increase safety, and reduce operational costs, especially on long-distance routes. Another area of great innovation is propulsion. Hybrid and electric propulsion systems are gaining traction, especially for short trips and in inland waters. These systems not only reduce greenhouse gas emissions, but also decrease fuel costs and create quieter, more sustainable operations. Digitalization is also transforming the naval industry. The use of technologies like the Internet of Things, IoT, and big data analysis is allowing real-time monitoring of ship performance, route optimization, and predictive maintenance. This means more efficient, safer, and economical ships. But innovations don't stop there. Naval engineers are exploring new materials and hull designs to improve efficiency and reduce environmental impact. Technologies like 3D printing and augmented reality are revolutionizing the construction and maintenance of ships. And we can't forget the growing concern for sustainability. The maritime industry is actively seeking solutions to reduce its carbon footprint, including the use of alternative fuels like hydrogen and ammonia. But with all these innovations, you must be wondering, how will they affect the size and weight of future ships? In the next topic, we'll explore the possibilities and challenges these new technologies bring to naval design. Get ready for some surprising predictions. The impact of innovation on ship size and weight. The technological innovations we discussed earlier are not only transforming how ships operate, but also redefining the limits of what is possible in terms of size and weight. On one hand, advances in materials and hull design are allowing the construction of lighter and stronger ships. This means we can potentially build even larger ships without compromising stability or efficiency. For example, using composite materials and carbon fiber can significantly reduce a ship's weight, allowing for increased cargo capacity. Artificial intelligence and autonomous systems can also influence ship size. With less need for crew accommodations, more space can be dedicated to cargo or passengers. Additionally, real-time route and operation optimization can enable larger ships to operate more efficiently. However, it's important to note that bigger doesn't always mean better. Environmental concerns and the quest for energy efficiency might lead to a trend of more compact and specialized ships. For instance, we might see an increase in smaller, highly efficient ships designed for specific routes or types of cargo. Electric and hybrid propulsion can also influence ship design. Although current batteries are heavy, advancements in energy storage technology could lead to lighter and more efficient propulsion systems in the future. But with all these possibilities, you must be wondering, what will future ships look like? In our next and final topic, we'll make some bold predictions and imagine what the sea giants of the future might be like. Get ready for a journey into the future of navigation. Conclusion: the sea giants of tomorrow. We've reached the end of our journey through the seas of naval engineering. We saw how physics principles still govern the design of the largest ships. We explored current limits and technological innovations shaping the future of navigation. Future ships will be diverse, optimized for specific functions. We can imagine autonomous vessels powered by clean energy and cruise ships that are true floating cities. Sustainability will be key, with intelligent and environmentally responsible ships. What do you think the future holds for the giants of the sea? Share your thoughts in the comments. Don't forget to like this video and subscribe to the channel for more fascinating content about the world of engineering and technology. All research sources for this video were cited during the presentation and are also available in the description. Until the next journey,